Hi friends, in this video, the very important topic, MMF method, or it is also known as Ampere-turns method. In this method also, we require open circuit characteristics and short circuit characteristics. Let's draw those characteristics here. Let's see. This is field current or excitation. Here EMF and the armature current. Draw the OCC characteristics. OCC characteristics are like this. We know this. And SCC characteristics are like this. SCC characteristics like this. We know this. Of course, here for rated armature current, the field current is IFSC, we know. And for rated voltage, the field current is IFOC. We know up to this. In EMF method, the measured voltage regulation is greater than actual voltage regulation because saturation neglected. We rejected that method. Then the fellow who find this method doing what to get the actual answer? See here, he doing to get the actual voltage regulation. How? This is IFOC and this is IFSC. Now he has to find the resultant field current, which is a sum of IFOC and IFSC. They decided to find resultant field current. How? For example, this is IFOC. If it is in unity power factor, then this is IFSC for unity power factor. Then this is the resultant field current. If it is at unity power factor. For example, if it is at a lagging load, then this is the lagging load. This is IFSC, and here this is the resultant field current. Somewhat more for lagging, somewhat more field current. And if it is in leading, for example, this is IFOC, and if it is in leading, this is IFSC, and this is the resultant field current. For leading, resultant field current is less. For leading, this is for lagging, and this is for leading. For leading, the resultant field current is somewhat less actually. So, like that, they decided to find the resultant field current here. Vector sum, this is Ampere-turns sum actually. Ampere-turns sum. MMF sum, we have to make it in MMF sum. So now the sum of these two may be, for example, this is my IFR, the resultant field current which is derived from these vectors. This is my IFR. So calculate IFR by vector sum of these two. Then find ER with respect to IFR. What is that? Just analyze the ER for IFR. Then for this IFR, the voltage on the alternator is taken as ER. Calculated. Now voltage regulation is equals to ER minus V upon V. This is the voltage regulation I calculated in MMF method. Very simple. This is clearly what MMF method. But once see here, I calculated voltage regulation at this point. voltage regulation at this point. Actually, how our synchronous impedance is like this. Our synchronous impedance is like this. Here, in this case, the measured voltage regulation is less than actual voltage regulation in final results. Again, there is a difficulty, there is a controversy. Sir, why? Why is like this? Why the measured voltage regulation is less than actual voltage regulation? Because the measured impedance here is less than the actual impedance, or the considered. Here, consider what we consider. The considered synchronous impedance is less than the actual synchronous impedance. Sir, why it is less than? Because more saturation consider here, more saturation consider. This is the difficulty in this method. In MMF method, saturation neglected, but in our MMF method, in EMF method, saturation neglected, but in our MMF method, what happened? More saturation considered, which is wrong. Due to that, synchronous impedance changes and voltage regulation also less than actual value. That's why this method is called very good, optimistic method. MMF method is also known as, they will ask you question like that. This is an optimistic method. And in general, I told you already, mainly drop due to XL and XA. Of course, armature resistive drop neglected. And in MMF method, total drop is due to, if they ask you question, total drop is mainly due to, if they ask like this, what you have your answer? The total drop is due to XA only, XA drop. Sir, why like this? What about XL? Here, the consideration is that drop due to XL is considered as, how they consider? Drop due to XL is considered as drop due to additional XA, additional armature reactance. This is the approximation in this method. So here voltage regulation is less actually, and here is a approximation. We don't know what is the drop due to XL and what is the drop due to XA separately. If you ask the question, sir, tell me, you calculated voltage regulation, okay, actually what is the drop due to XL and what is the drop due to XA? If you ask you question, I am sorry, I don't know what is the drop due to XL and what is the drop due to XA, but I know that the total drop is due to XA only. I know the total drop. I don't know what is the total drop due to XL and what is the total drop due to XA. But I know what is the combinedly drop. I will give you answer. But this is not correct. We should know what is the drop due to XL and what is the drop due to XA. But that information is not given by EMF method and MMF method. That's why these two are worst method. One is the pessimistic method, one is the optimistic method. Of course, these two are worst method, but these two are very important for our examination. Are you okay? Getting or not? So this is simply what is Ampere-turns method. Right? Thank you.